In this video, we'll discuss some of the useful symbolic math operations that you can perform using MATLAB. This requires installation of the Symbolic Math Toolbox, which is already there if you're using MATLAB online. We'll start with the symbs command. The symbs command is used to define symbolic variables. The only delimiter you need in your list of variables is a space. So I can define the symbolic variables x and y using this command, and now you can see that x and y both appear in my workspace. If I then define functions using x and y in the expressions, now f is also a symbolic variable. F is a function of the symbolic variables x and y, and so it can be differentiated with respect to either x or y. We can take the partial derivative of f with respect to x using the diff command. And we have to tell MATLAB that we want to differentiate with respect to x. The partial derivative of f with respect to x, of course, here is 10x. Similarly, we could find the partial derivative with respect to y. To find the second partial derivative, we could do it one of two ways. The easiest way is to add a third argument to the diff command, indicating the order of the derivative that we want to take. Of course, we could also simply take the derivative of the df dx that we already defined. The subs command is one way that we can evaluate a symbolic function without converting it to an executable function. To illustrate this, I'll create a new set of symbolic variables, a and t. And I'll define the function f as a times the sine of t minus 2a times the cosine of t. Notice that in symbolic functions, there is no implicit multiplication. We still need to add the multiply signs between all of the multiplicands. Once f is defined as a symbolic function, I can now redefine the symbolic variables a and t and then evaluate f at a equals 1 and t equals 4 using what's called the subs command. The subs command takes an argument that's a symbolic function. This tells me that f at a equals 1 and t equals 4 is the sine of 4 minus twice the cosine of 4. If I want to convert that to a number, I can use the double command, which asks MATLAB to tell me what the double precision value of f14 is. I don't think that this is a particularly useful method for evaluating symbolic functions, and here's why. It requires that we redefine our symbolic variables as numbers. Now, a and t are no longer symbolic variables. A is equal to 1 and t is equal to 4, as you can see in the workspace. In a little bit, I'll show you a better way to do this. But first, I want to correct something in your textbook. When the author of your textbook wrote this, he was using a previous release of MATLAB. You have to go back to MATLAB 2016 or perhaps MATLAB 2017 for something like this to work. Your textbook says on page 37 that you can do this. The single quotes here indicate a string, and the sim function is supposed to convert this string into a symbolic function. But it doesn't work. This syntax is now obsolete. It's easier just to use the symbs function. So use the symbs command to define the symbolic variables x and y, and then define your function this way. Do not attempt to define a symbolic function using a string, as your textbook suggests. Since we know how to do differentiation, we can expect that MATLAB also knows how to do integration, which of course it does. I can integrate the function f using the int command. So the integral of f with respect to x is found using the int command with two arguments, the symbolic function and the variable with which we want to integrate. Similarly, we could integrate f with respect to y I showed you before that these symbolic functions could be evaluated at particular values of the variables using the subs command, but I cautioned against doing that because it requires redefining the symbolic variables as numbers. I think a better alternative is to use the MATLAB function command. The MATLAB function command generates an executable function from a symbolic function. I'll call the executable function capital F. When typing the MATLAB function command, remember that the word function is capitalized. Capital F is now what MATLAB calls an anonymous function, and lowercase f is still our symbolic function. Now we can evaluate f at any values of the two independent variables that we choose. And we don't have to redefine x and y in order to do that. We can still retain x and y as symbolic variables. We can retain lowercase f as our symbolic function, and f, capital F, as our anonymous function, or the executable version. In the next video, we'll also show that MATLAB is proficient at performing Laplace transforms and inverse transforms. And MATLAB can also be used to solve differential equations.